All right, hello and welcome back. New record, 2 videos in one day. So this is one more ALEKS topic that's called calculating electrostatic energy using Coulomb's law. And there's a variety of different ways that we can do this problem. I'm going to show you what I would say is like the most straightforward, the easiest to conceptualize way to do this problem. And basically what we're going to do is we're going to have to figure out really what information is useful for us to use this method that I'm going to show here, and what information is not that useful. So basically, if we read through this, we've got an object with an electric charge of minus 0.85 millicoulombs. So this m here, it's not the funny looking m, it's just a normal lowercase m. That is millicoulombs, is some distance away from an object with an electric charge of minus 0.730 millicoulombs. Again, the electric potential energy is measured to be 58.09. So this is basically sort of setting up, a situation where those two objects that are charged are a certain distance from away from one another, and we can measure their electric potential energy. Now, the question that we're asked to solve here is really right here, is just given these two charges, calculate the electric potential energy of the system when the objects are 19.2 meters apart. So even though we're given this information of, when they're 96 meters apart, this is the electric potential energy, we don't really need that information. We can use it if we want to solve this problem in a different way with a different method. But the method that I'm going to show right now, basically we can ignore these two pieces of data. We don't necessarily care. We're just going to calculate this directly. Again, there is a different method that you can use, and if you use that, that's great. That's fine. Don't get caught up on, well, one method's better than the other. They're just two separate methods. So for the method that I'm going to show, we can actually ignore this part of this original data and just focus on the charges and the fact that they're in the question that we're trying to answer, they're 19.2 meters apart. Okay, so I've got a bunch of stuff written out right now. So the first thing I'm going to draw your attention to is right here. This is just the data, basically. This is Q1, the electric charge, Q2, this electric charge here, the distance that I care about, 19.2 meters, because this is the question. And then here is the value for K, that's a constant. So the reason that I pulled this out basically is that I know that for this problem, this is the equation that we're going to really need to use. This is going to be the equation that we're going to do to calculate the value of U. So the electric potential energy of the system, that's this U. This is what we're trying to calculate. So this electric potential energy, that equals U. That's what we're looking for to calculate. And this is the equation K Q1 times Q2 over R. That gives us the electric potential energy. So now we're going to start putting these two things together. So Q1, Q2, those are our charges. So that comes from here and here. R, that's this distance here, the distance for what we're going to try to calculate. And then K, like I said earlier, that's a constant. So basically we've got all the pieces that we need except for one thing, units. We have to do our unit analysis. So what we're asked for is to calculate this in terms of joules. I actually don't know that it says that in the question, but that is the what we're looking for essentially. So we're going to have to enter this with a certain number of joules and 3 significant digits. But joules is always, in every example that I looked at, joules is what we want essentially. So this K value has units of newtons times meters squared over coulombs squared. Q1 and Q2, those should have units of coulombs, right? So basically in this unit analysis, we want to make sure that everything is essentially consistent. So if we're using coulombs here for K, for our charges, we also need to use coulombs. And we'll notice that our Q1 and Q2 we're given in millicoulombs, so we're definitely going to need to convert those. R is in terms of meters. So this R here is in meters. The R that they gave us here is in meters as well. So that's great. If they did give it to us in centimeters, we would have to convert that to meters. And then basically everything else here, all I'm really doing is just looking to make sure that everything is consistent. So the fact that K was given in newtons times meters squared over coulombs squared. That made me actually go and look up what the units for a newton are, and that's kilograms times meters over second squared. The unit of a joule, again, I looked that up. I just Googled it, units for joules, and I got kilograms times meters squared over second squared. So essentially, all I'm doing over here is just making sure that everything is consistent. If something is different, then I want to look that up. I want to figure out what those units are. And essentially all this is telling me is that I need to use coulombs for Q. I need to use meters for R. That is really the take-home message here. Those are the things that I'm going to need to convert if I need to convert it. And once I've done that, then I can basically just plug it in and go ahead and do the problem. So let's start doing the math. So Q1, we'll put it right here, is equal to minus 0.850 millicoulombs. So we need to convert this from millicoulombs into coulombs. So I know that milli is 10 to the third, just like milliliter and liter. It's the same exact thing. And that 1 coulomb would be the equivalent of, you could write this out in a variety of different ways. You could write 1,000 millicoulombs, just like we would write 1 liter and 1,000 milliliters. You could use 1 times 10 to the third, however you want to write it out. It doesn't really matter too much. But then we can go and do this calculation, and we get a value of minus 8.5 times 10 to the minus 4th coulombs. So that's our value for Q1 in coulombs that we're going to use in this equation. We'll do the same thing for Q2, minus 0.730 millicoulombs times 1 coulomb over 1,000 millicoulombs. Personally, I like writing it out like this. It seems easier to me. It makes more sense. And I don't make as many mistakes, which is always good. Times 10 to the minus 4th coulombs. And now really I've got all the pieces that I need to basically just plug this into this U value here. So let's go ahead and write that out. So U, which is what we're looking for, that is the electric potential energy, is equal to K, which is this value here. So we'll write that out, 8.98755 times 10 to the 9th. Times Q1, which is this, so we'll put that up here, minus 8.5 times 10 to the minus 4th, times Q2, minus 7.3 times 10 to the minus 4th. And that's all going to be divided by the value of R, so going back up here, by the value of R in meters. It's already given to us in meters, which is convenient, 19.2. And then we basically just need to do this whole calculation. And we end up with a value of 290.457. And that would be in joules. And then we're told to round our answer to 3 significant digits. If we look at the data that's given, everything was given in at least 3 significant digits, and we're basically just converting and plugging in. So, if we had to figure that out, I would just look at these numbers and make sure that they all have 3 significant figures as well. So we're going to round this to 290 with a decimal point. The decimal point is very important here because that 0 is significant, joules. So be very careful with things like this. You could always write this in scientific notation if you wanted to make sure that you were entering this correctly, but this should be sufficient as well. So hopefully that answers your question about how to do this calculating electrostatic energy using Coulomb's law topic. Basically, this strategy that I've shown here can be used for all of these instances. All of these problems you can do this way. And like I said at the beginning of the video, there is a different way to do it if you can figure out the different way and it is a little bit quicker, that's great and you can use it. But I don't want to teach that necessarily because I think that it can cause some bad habits. So this is the method that I would teach. It will get you to the right answer, and I think that it's good. So let me know if you've got any questions in the comments below, and thanks so much.